Well, thank you for coming. I know it's a bad moment for many students because of the midterm reviews, etc. But it was an opportunity to have Frank Barkov with us, and we have a schedule today. Frank studied architecture in Montana State and at the GSD. He has recently taught at the Royal College of Art in London, the EPFL in Lausanne, Harvard GSD, and University of Wisconsin. In 1993, Frank Barkov and Regine Levinger founded their practice in Berlin. Their interdisciplinary discursive attitude allows their work to expand and respond to advancing knowledge and technology. I mean, this is why we have invited him, in this case, to speak. This know-how contributes to recent projects, including a house and factory campus event space in Stuttgart, in Germany, and the Turtec office building in Seoul. Current research projects have focused on digital laser cutting, infrared concrete, facade systems, space frames, and ceramic elements. He will be showing us a few samples of his last innovations. And I just want to add that his work has been exhibited recently at the Biennale di Venezia or at the Architectural Association, and his work forms part of the Museum of Modern Art collection and other museums. Well, with this short introduction, please welcome Frank.
It's fantastic to be back here, and it's a short presentation today, but I wanted it to have, or at least be able to have some bearing on the workshops we'll be doing this week with Jörg Consett and Eric Haller's group. This little talk is also on the back of a symposium we had at MoMA in September about the idea of the pursuit of architecture, how ideas translate into buildings. This is something that's kind of at the heart of our practice, how we think, how we work. It's been quite important for us how that works. So I wanted to sort of think about the talk in that kind of context. I think, like many of practices of our generation, I think this idea of working between a research project, an academic project, and the practice itself is a fairly common one, a fairly clear one in terms of how to work, where these sort of work areas inform each other. And this little soundbite up here is really about our time at the GSD, which was late 80s, early 90s, with Moneo, and this idea of a kind of physicality in architecture, that architecture is really a material practice, and it really is the transformation of materials that really leads to a kind of architectural idea or ideation. So some of the things we've been doing, and I'll do a quick forward before I focus on one project that I wanted to go into in a bit more detail, but this idea of tools, both digital and analog, in the practice. What are tools, what are emerging technologies, how can we use them in the practice, and how can that inform a making of an architecture. So I think when we were students, I mean, this was probably, you know, the kind of workflow that we were contemplating. This is how things work. Software was starting to emerge, it would lead to materials and tooling. More recently, it kind of works like this. So in a way, what's interesting about that sort of an approach is that it allows the work to differentiate. It allows toolings and technologies to drive the work forward. This means we're constantly accumulating partners that have different skill sets as related to material and their transformation as a kind of way for us to work with partners as a kind of becoming our own best experts in terms of how processes can happen. This also means working with engineers, as we'll be working with Jörg Consett this week in a kind of upfront process where we're working with engineers at the beginning in a workshop process in terms of understanding these things again in a more integrated approach in terms of engineering methods and architecture works together. In order to do this, I think in the last 5-10 years, this idea of an atlas of fabrication, where we started to produce in a way our own building catalogs, not so much to document buildings per se, but to document processes, typically through activity, through action, upon materials, through tooling, as a kind of self-constructed project within the practice we can add to. When we initiated the first catalog, and I have a few of these catalogs floating around, so I can drop some with the school, was complemented by an exhibition first at the AA in London, then later an exhibition in Berlin. But this was a way, almost kind of like a natural science museum, or thinking about the idea of a, say, atlas, the way, say, Gerhard Richter would, as a kind of series of outtakes or outcuts that are in a kind of not architecture yet position, in a way latent to be used or instrumentalized for our building processes. At the same time, we began to research and document the capacities of different tools. Working with GSD students, a lot of students coming in would actually go down to the factory sites, look at machines, look at tools, again, both digital and analog, and see, again, in a very sort of open-ended, experimental way, what the capacities of those machines were and what they could do in terms of transforming materials. So in a very compressed sort of timeline, those were sort of experiments leading to, say, a project of this at the scale of a kind of prototype and installation scale, to a further development of that idea as a kind of facade idea which could rotate for both performative ideas in terms of sunscreening at the same time, for the showroom in Sweden, show the content in the inside, have a sort of aesthetic effect, while as a kind of timeline between these things. Other sort of research areas included space frames, studying them both, space frames that developed in the 60s and 70s, and then looking for applications of these kinds of techniques, these kind of architectural elements, in this case as a facade for the Kunstmuseum for the Zurich competition a few years ago, including a few years ago a studio we did here at the GSD with Chris Bangle, the head of design at BMW at the time. This idea of looking at other disciplines, particularly in Germany, which is, you know, well loaded with lots of technology firms that are doing different things. In this case, looking at Gina, which was an idea for a fabric, skin for a car that's kinetic, it can move, it can change on the car, and sort of rethinking or rebooting this idea as an idea for housing. In this case, this is a project from Nacho Galan for a housing thing where development where the buildings can move, they can change, they can respatialize, they can reorient to sun orientation. Again, using this technology from the auto industry and then revisiting that project in a sense at the scale of housing. But the project I want to focus on today is the so-called Smart Materials House. This is the image of the project as we presented it. This was organized by Arts Plus Magazine. And the IBA in Hamburg, a couple of years ago, the idea of the IBA, which has been around in Germany for 80, 90 years, has been an idea to provide low-income housing, to be experimental. Berlin famously had an IBA in the 80s. But the question of this particular IBA was smart materials. What are smart materials today? How could they inform an architectural project? And how, in a sense, could that inform this idea of a kind of project here in Williamsburg? This is Hamburg's Hafen City over here, where the Herzog de Meuron project's over here. But this is a kind of sketchy industrial part of the city where we were asked to look at a site over here on the corner to test this idea for about 8 or 10 flats of apartments. So in order to start this project, what we did is we began shopping for materials at the outset of the project to see how that might lead to the building project. So we, with our engineers, which included in this case Mike Schleich, who's an expert on interlight concrete, which we ended up using, and Matthias Schuler from Transolar has been teaching here at the GSD as well. So what we ended up doing, looking at sort of CO2 impact, was to select two materials that at the outset it seemed sort of strange to have these together. And this sense was Infralight concrete, which is a self-insulated concrete, combined with timber, which is good in tension for the floor plates. So this is this material. It's 1/3 the weight of regular concrete. It's insulated either with recycled glass or clay. It's in the sense that it's self-insulated. The thicker it is, in a way, the better it is, which can be combined then with timber for the decking of the project. At the same time, we were quite curious about the history of prefabricated concrete in places like Germany. This is Khrushchev in 1957, inspecting a model showing the Plattenbau construction, which would work on these kind of rail lines. The Plattenbau, this plate building, populates the entire Eastern European cities and countries as a way of economical, cheap housing. At the same time, it could differentiate. You could have very different sort of programs and facade systems within this idea, including the idea of the arts programs, which were also embedded into the project. At the same time, and this is a conversation with Matthias, what's concrete and how could one exploit the sort of plastic potential of the material, the idea of shaping a material that's entirely different than others. So some of our first sort of sketch projects were, in this case, thinking about a smart material, a self-insulated concrete that could pin together to hold a wood construction together. The idea of a wood high-rise in Europe is something that's not very far away, particularly in countries like Switzerland, Germany, Austria, sketches and projects like this. This was a project for a kind of box beam space. This is also, I think, a project that was inspired by some of Jörg's work, where that space can be occupied, it can be programmed, and through this sort of self-stabilizing history of wall making, this box beam could span up to 20, 30, 40 meters. At the same time, with this particular material, we returned to the idea of poché. Until recently, high-tech was always about lightness, about steel, about glass, about combining. And here was a material that actually benefited or profited through its thickness, through this idea of poché. So in a way, that was also the chance to revisit a kind of historical project. Through our earlier fabrication research, we know how to do formwork. So we were pretty confident in terms of doing more complicated formwork. The idea of prefabrication, which usually wants to be about modularizations, making the same thing over and over again. We realized we could pour things at different heights. You could take elements, flip them upside down, make a different kind of element, and started to create a kind of form language, or almost a kind of alphabet of different building elements which we could combine. In the end, we selected this element, and again, for I think a combination of performative potential as well as a kind of formal one. The idea that the shape could be self-stabilizing, self-standing, it wouldn't require any kind of scaffolding to put it up. All the heating and cooling can be embedded in this element, which is about 60 centimeters thick. It can use mass radiant heating from the solar sort of collection, but at the same time have a kind of spatial effect both on the interior and the exterior of these spaces, and the scaling of it was important too. So for us it was important, we knew this is going to be a kind of domestic space, so the sizing it, combining it with deep wood windows, and then started to produce this idea of a stacking, which in a way works like a house of cards. You can stack these elements on, so you see 3 or 4 floors here superimposed over each other. Because both the wood and the concrete is self-insulated, pieces can overlap with each other without causing cold bridges, sort of warm bridge problems. So again, that was a kind of aspect of the project that could enable this kind of form making. At the end of the day, in terms of parts, there's relatively few. I think we had 3 different types of walls, and then combined it with wood windows, which are triple glazed, and then with the addition of a kind of outside acoustical layer, because the site here is quite loud. And then how it's produced was another important factor. So the pieces can be trucked on site. They can all be prefabricated. They can be brought on site so that the entire rough construction can be built in, say, a week or 2. So not only what the pieces are, how they work, but how they could actually be sort of collected on site and put together in a very quick way. Again, having fairly a number of ideas about sustainability, about the engineering of the building, how it would perform on this site, as well as the economics of the project. So in the plan making, and again, because of the capacity of the material, it allowed each plan to be different and to be able to overlap in a kind of nice square grid where it can either be quite open, like a loft space, or it can be divided into more cellular room making this way around either a wood core or a concrete core in the building. So in this view of the project, you would see it as a kind of open loft space. The thickness of the walls is a way of conditioning the light, how it comes through the space, in combination with a relatively reflective wood decks that frame it, with a concrete floor to help with the acoustical separation between the units, and then to kind of create this undulating perimeter, which again has a thickness for letting the light, which can be given over as a kind of loft space, 3 or 4 meters high, or again divided into, in a way, more traditional rooms. For us to understand the project, we started making large-scale models in the shop at our practice, which is where we do most of the design. So, and we wanted to build it as close as possible to the real thing, so we made it out of this kind of ugly pink foam that you could stack over each other. But by building these modules, which we could build quite quickly, we could see quite clearly how the structure would work on it. We could see quite clearly how the spatial depth would work in the project from the exterior, where it makes these kind of balconies, as well as the interior, so that the project had this kind of, dynamic 3-dimensionality, and a kind of reversibility, where the front and back of the pieces condition either an interior or a kind of exterior like this. Again, we had about 3 types. You could flip the types, the elements upside down and produce another one, or you could pour them at different heights as you needed in a fairly flexible way. So by the time we had won the competition for the IBA, we submitted this for a prize for the Wholesome Foundation on Sustainability for a Global Innovation Prize, and they gave us enough money to build an actual prototype of one of the walls. So this is the clay aggregate, and then this was the formwork that we ended up producing with CNC technologies, and then produced these one-to-one elements, which this week we're testing in terms of finish, in terms of polished finishing or sandblasted finishes, in terms of how we could use these further. At the same time, the idea of it being a prototype was important, which meant it could adapt to different kinds of programs. In this case, this is for Hamburg also, a pavilion project where it now becomes a kind of one-level project with a courtyard as a kind of circular route through the project. But for us, it was also interesting to understand the kind of limits of the construction system in terms of typology. It could be for housing. We could use it also for kind of exhibition space or a prototype. And in the latest iteration of the project, we are now focusing on the Karl Marx Allee in Berlin for the urban living project, which is in a way is an even sort of better way of situating the project in the context, again, if you go back to the Khrushchev image, in the context of kind of prefabricated Plattenbau context, and looking at different sites within the Karl Marx Allee where this particular project could be located. So these, and again, this is from like a week ago, so this is hot off the press. But looking at towers now located within the context of, and for us in a much more urban context, of the project in the Karl Marx Soleil. How am I doing for time?
Yeah, very good. You have 5
Oh, 5 or 10 minutes, okay, okay.
Not very good.
I was going to show this in more detail to the students, but this is a project we just finished, Tour Total, in Berlin. This is related to the other project in terms of precast concrete for a facade that in a way belongs to the history of Berlin facade making, a raster facade or a kind of gridded facade. I guess here you might call it a Chicago frame, which is in this case a kind of exoskeleton. The facade is connected back to the floor slabs through a number of isolated or insulated connections back through here. It was important for us to have a facade, unlike the curtain wall history maybe here, that had a kind of spatial depth to it. It has exterior sun screening. It's also the same idea as the sustainability idea. Through the closed surfaces, produces a better insulated surfaces, and then using, again, our techniques or technology for the production of the precast elements that were made off-site in Frankfurt. They're extremely precise in a white concrete with a kind of acid wash to them. Again, the digital realm sort of means that we could produce 160, 170 different types for this one particular building. Of course, some of them repeat, but we could produce a huge variety of pieces that could come together and assemble to make this building. So at the point where a kind of independent facade and exoskeleton, in a sense, that can be connected back to the floor slabs, for us to be both a kind of historical quotation for Berlin, at the same time innovative in terms of technology, and at the last sense, I think, produce a certain amount of aesthetic effect that we were looking for. So I think that's the last slide I have, actually, so you'd be okay. But this was this idea of what we're doing with concrete right now in terms of one sort of focus area that, again, I hope it's helpful. And I'll go into this in more detail, Eric, I think later in the week with your students in terms of the idea of envelopes and facades. But I think in the context of this talk, I wanted to really focus in on one particular project.
Thank you, Frank. Thank you for this wonderful short talk. And as many of you know, now we have like 3 people responding in. One is faculty, which is Eric, Eric Howler. You all know him. He's very. He has been. Yes. We have DDes and MDes student, Matan Meyer and Joe Stout. All of them have some relation with Frank, so this will be a conversation among them, and then we will open like 5 last minutes to the rest of the audience. Okay? This is the format.
Thanks, Frank, for updating us. As Frank come and talked to my class a couple years ago when I was teaching here, so it was great to see that new work was being produced as a kind of series. Every time I see Frank, he gives me a publication, something, hot off the press sort of publications. A couple years ago, Frank lectured in my materials and construction class, and he showed a series of projects that were sort of organized by the process. It was cutting, pressing, stamping, bundling, and I think that's a kind of, as he said, a kind of process-driven material practice. And I think that's so important that as we are sort of living in an age that's so obsessed with digital tools, and I think Frank is able to sort of span between a kind of contemporary digital practice to a highly material practice. And I think that's so valuable, particularly in the context of the school, where students are engaging not with construction, but with design, anticipating construction. Actually, the 3 of us were teaching a class, and the challenge was, how do we talk about contemporary construction? Not fabrication, but construction. And I thought it was interesting to think about the difference between construction and fabrication. All students are engaged in fabrication at some scale. But when we talk about construction, we're involving different trades, different disciplines. And I think it's hard for students to sort of go from the laser cutter bed, 18 by 30, to the scale of the building. And that gets me to an issue that's sort of fundamental to architecture, the kind of particle relationship. How do we scale something up? From a technique that's sort of based on your screen or on the bed to a building scale. And so I've been sort of very, very interested in watching Frank's work evolve from processes. There are processes that are scale specific, but you can imagine using digital tools to stamp a material. And I like the way you said, we make a thing to make a thing. We can visually fabricate the formwork, and that helps us make the final piece. And that's one way to scale up. I think thinking as students about digital tools that they're very adept with. How do they make the gap, bridge the gap to construction? How do they work or partner with industry to bridge that gap? I think we have an expertise that maybe industry doesn't have, which is, maybe companies, some of the companies you mentioned, concrete companies or chemical companies, they have access to very sophisticated materials and processes, but they don't really know the applications. And I think sort of manage to bridge between sort of processes and applications. I think that's one potential role for design, is finding that link between industry and application. So I wanted to sort of open up a little bit, just talking about the difference between construction and fabrication, how architects work in contemporary practice to sort of make those connections, to offer opportunities to both scale up technologies that industry may not be familiar with. I think some of the work you've done for Trump has kind of shown new applications for existing tools. But to think also about materials and techniques more precisely as architects, sort of finding, almost finding projects within existing technology. As a mode of research to open up new places for architecture to be innovative. It's not necessarily innovative from a simply form point of view or simply software point of view. But I would say what's truly innovative is finding applications for kind of material process that the industry may not have known previously, or I wasn't aware of previously. And eventually I sort of want to talk about the question of scale, because I think students are obsessed with what they can laser cut, what they can 3D print. And I think you've sort of found ways to sort of amplify that, to find application. I love the explanation of extrusion. You just keep extruding, right? That's one way to scale 1D. But the question of part-to-whole scalability and the kind of specific material processes that allow you to sort of go from research prototypes to full-scale architectural construction.
I think what happens in architecture is it's a lot messier than at that scale, the kind of maybe at the shop scale project. I think what happens is it becomes a much more of an inclusive system. So I may be working in digital technologies, but often we're working in very primitive technologies, or I would say conventional ones, or translating digital drawing to, say, a site in Marrakesh where we're building things by hand. So in a way, I think there needs to be a series of operations that end up sort of mediating through scaling, because often we have thought, let's make a building facade like a car manufacturer would make a car body, but in fact there's a lot of giving way and a lot of bringing in other ways of working or fastening or bringing things together that in a way is much more complex, and I would say more hybrid. So I think what's true about it is it's not a kind of inclusive way of working where digital means will simply produce buildings, at least maybe not yet. But another thing that in terms of ways of working, and I think the catalog talks about this also, is the idea of representation, where often the representation is drawing that's instrumental for making something. So there's a favoring of working one-to-one, and in many of our workshops we'll do this with one-to-one production to test the thing as a physical thing, but also as a visual or spatial thing. So I think there's a kind of shortcutting that goes beyond that. When we were students here, we were exclusively working in representation that was anticipating these larger and more complex scales, and I think what's interesting now is by becoming your own expert, you can sort of shortcut this thing, or working with firms who themselves are curious and looking for new applications for the work. We're talking with Audi and doing these things, how you can take these things on board and transform them. So I think as through these, say, emerging technologies, how you can use them, I think it's very much hands-on. I think it's somewhat unpredictable, but there is a kind of, again, transformation of the idea through these workings that produces an outcome that does scale up. And I think where we fail is when we try to take something at one scale and simply blow it up. And then there's usually a critical failure that illustrates you simply can't do that. It won't work through efficiencies, through the economics of the project, et cetera, et cetera. And so those ways of where does the project give way and where can it adjust to this sort of new reality or this new scale is quite important sort of series of steps through a process.
I was very intrigued by the Smart Materials House that you presented and how it was using simplicity in a way and like innovation through simplicity and this really integrated simple system where you just take the material properties and you avoid all the layering that we usually see in contemporary architecture.
Yeah.
And you solve all these problems just through the material properties. Is that something, because I think that is something that we see in several other practices as well, that people try to go back to the material properties and extract as much power out of that.
Yeah, I think so. I think the idea of the one-stop stopping or the multitasking element was extremely an attractive one because one thinks technology is about complexity and generating more complexity or layering or things like this. So I think that the fact that they did have this simplicity. What's interesting to me about that project is, I mean, as we speak, it's evolving. The energy codes in Germany are constantly becoming more and more strict. Even that section, which I showed, is already in a way obsolete. It's now about sections that are have a kind of gradation of insulation to it, or hybrid systems with additional insulation on the inside. So, but I think for us, smart didn't necessarily mean high tech. Or again, I think this may be at the root of your issue here is how do you make a technological idea, an architectural idea, or a spatial idea? And for me, this idea of a kind of where all those things are one in one thing, I think is the interest. So it wasn't about, and our friends from Chancellor, they hate this idea of sort of simply tacking things on your building to make it smart or make it work a certain way, but that if you can find that position where those ideas sort of coexist in a new entity, for us that was the most exciting idea of say, invention or a kind of idea, the innovation of how you could do something. At the same time, I think we still believe in looking at history. I mean, we still go, our students who go back to our history books and look at how buildings work that had thick walls, or but also histories of buildings, but also histories of production, how things were made, how were things made 50 years ago or 20 years ago, or how will things be made for us in 3 years from now is also a really interesting idea for us. So I think, and again, this is probably the most pure sort of evolution of taking two project materials and really driving a project with that. But, and most processes are much messy, you know, back and forth and using this and off the shelf versus this and that. But I think for me, this time, I think, and also for students, I think this idea of this trajectory of all these things coming together to form an architectural project makes it an extremely interesting time for architecture now. And you as a designer or architect, I think are really empowered. I mean, to make these decisions yourselves. I think again in industry there's nothing standardized. They are all curious. They're all looking for new ways of doing things. So I think for you as a student, I think for us in a way, I mean there are limits, of course, economics, etc., but at the same time there are amazing set of sort of freedoms now in terms of what architecture is and how it can be made. Looking into again, I'm thinking of the very near future, the next 5 or 10 years.
I'd like to continue discussing a little bit the smart materials part. And I mean, the whole idea of kind of collapsing the residential envelope into one layer is very compelling. And this whole notion of, you know, the notion of simplicity of materials is really intriguing. And I think that the interesting thing about it is that it brings up this whole series of questions that as architects we usually tend to kind of ignore because they are embedded in the, you know, if it's here in the Northeast, in the kind of timber frame envelope where you have 7 or 8 different materials that have different, that each one has different properties and aims for different, to solve different problems. But the whole idea of structure comes up. I mean, in the project you showed, I'm assuming that the columns are somewhere inside those envelope walls. So structure is an interesting thing that comes up. The whole idea of flexibility. I mean, how do you change the envelope over time? I mean, even in terms of embedding systems into the envelope or maintaining systems. So the whole idea of the whole problem of maintenance and eventually the whole idea of end-of-life solutions. I mean, how does it eventually come apart? How does it recycle? How does the walls? How do the concrete walls connect to the glulam slabs? I mean, all these. I would like to hear a bit more about all of these issues.
Yeah, again, I mean, the kind of multiplicity, again, the element is the column, is the wall, is the heating system, is the cooling system, it's all the same. So, I mean, and because it is so elemental, the connection is quite simple. I mean, the connection, which is, you're right, I can show more detail about the connection is simply a pin, where it's put together. So in a way, it can be reconfigured.
Yeah.
If needed, it can be reconfigured internally in terms of, in a kind of conventional way, moving partition walls. But it also can be reconfigured, I think, physically. The whole thing could be demounted and taken apart. The life cycle for concrete is probably know, is quite a long one. And because the materials come from a recycling technology, they can be recycled, downcycled. So that's kind of the inherent system idea with it. So and right now it's just it's getting the economics and the project to work out so that where it's situated, again, urban or suburban or ex-urban, deciding of it, economics is a kind of interesting thing. Off-site production, where did that happen? Where does that happen? So I think, as you're suggesting, I think it sets up the next series of questions in terms of how you execute it. But I think in presenting, I still think it's late with the ideas for doing this. And again, as I said earlier, it's something that's changing. It's already, some of the things we're proposing here are already obsolete. So we need to look at a new wall section or a more complex one. Or it's limited. This is a system that's limited to 5 or 6 floors. What would this mean for high-rise? It would beg a kind of parametric solution of, as you're suggesting, a kind of load-bearing column with a kind of crochet wall that's more, almost a kind of hybrid between, it'd be a cool project actually, a kind of curtain wall condition and a load-bearing facade in one, which is fabulously strange and interesting.
Which is kind of what this project also suggests.
Yeah. So if this thing was 30 stories, 50 stories, 100 stories, and World Trade Center down there, I mean, it would be an incredibly interesting problem to solve. But it's, and I've had some of these conversations with Jörg also. But I think, I mean, it's sort of getting close to them. But I think these things that we looked at as one system or another are becoming, in a way, a much more complex hybrid system. But I think even a small project like this could, and going back to your issue about scalability, I think it begs, or it opens up really interesting questions in terms of things like this. How do you build a wood skyscraper? Why would you do that? How would the facade be? How would you fire it? All these things become really interesting. And there's sort of demands that, again, I think, drive a kind of architectural proposition. You guys were talking about zoning and these kinds of things, but I think these issues also set up some really interesting questions, and particularly in a country like this, which has these histories of, say, wood construction, the balloon frame, a fantastic history of ceramic and terracotta construction in the Midwest. These are all kind of historical capabilities that have also been forgotten, that could be looked at again. So I think, so when I see, the kind of usual everyday construction here, I'm always reminding myself that, in a kind of Donald Judd way, he also built fantastic bridges and dams, and there's a whole kind of history of construction here that, in a way, sometimes gets backlogged or forgotten about.
Thank you. No, I want to open the discussion a bit to the audience, but I don't resist to make a comment on what you have said about this new condition that we are constructing in many ways. A material condition that changes, that reverse the idea of the light construction into a kind of more massive or more a hybrid, I would say, combination of different materials. And I think that every change in architecture has a kind of immediate physical response, even more than stylistic. It's like the first effect of every revolution or every evolution. And I think that, I have called this a kind of thermodynamic materialist. It can be called whatever, but the whole idea is that we are shifting, we are changing our mind, and we are beginning to look at other materials, at other processes, and we are trying to make much more synthetic constructions, able to respond to many different conditions with the less material, but this material can be really massive at the same time. So this is a kind of a complete change from this American standard, I would say, of the structure and the envelope. This kind of radical division. Now it's the whole material of the building is acting, is performing, as in the social housing that you have proposed. The slabs are as important as the facade. All this create a kind of three-dimensional. Every single square inch of each material is performing in a kind of hybrid and synthetic way. And I think this is clearly the path we all are trying to construct in many ways. And I consider it extremely important. But said that, I just want to open the questions and answers from the public. Yeah, please.
Thank you. You started your talk with this triangle diagram of practice, research, and the academy, I think. Could you comment on the economic configuration between these three realms within the European context or in Germany? I'm curious of what is the economic engine behind experimental and speculative work there?
I think between those three, sort of, I think one practice, academic, and what was the other one? Practice and research. But there's a lot of shuffling back and behind. So it's really based on opportunity and exploiting. If we can research something in an academic setting like this, like the GINA project, then we'll do that. If it makes more sense in the practice, we'll do it there. So I think there's a lot of shuffling. What I like about school, obviously, is there's a different. Sometimes constraints very good. Sometimes a little bit of unconstrained is really good. So the more speculative work happens in both places, but it's somehow different in academic. What I like about the practice is simply the resources of engineering and companies at the doorstep. Make a phone call and they come over here. So it has this kind of realpolitik of actually touching base and finding out how these conditions work and how you can use them. So I think the research and we're in the European system of doing competitions all the time, and if you simply do competitions to try to win them or lose them, you go crazy. So I think there's always an idea of placing a research project within things like the European competition system. If it's the idea of the or it's the idea of the space frame, or a kind of material condition, the smart materials. So I think it's really about a kind of agility to move between these areas and as fluid as one can, and to exploit what the advantages are. In an academic setting, obviously there's advantages that are different than the opposite and vice versa. But I think that idea, it's really about maneuverability. And again, I think like your practice too. You know, I think it's about, you know, it's not about doing the same thing over and over and over again until it's perfect, but it's finding a set of circumstances for each project that have the potential at least to be unique. Again, we don't reinvent the wheel every day, but it seems to, arguably if you had a practice 20 or 30 years ago, it would be very different than how we're working today. And I think whether it is, scarcity, low, income or economics or material that situate each project, and I think that what makes the practice quite interesting. Sometimes it's very meager. Sometimes the site for architecture may be simply the elevation on a project that through zoning, through this, and go master planning is what we're working on today in Berlin is incredibly confined versus a project like this, which can be fully sort of realized through all of its connectivity, through its material, through its programming, in a kind of comprehensive way versus other projects where it's more targeted, I would say.
I really appreciated the presentation, and clearly your practice has really done an amazing job at material research. And I wanted to sort of get to the topic of smartness, smart materials in general. We hear that term a lot in terms of smart buildings, smart products, smart materials in general, and your project even brings that up. But I was wondering if I could put you on the spot a little bit and sort of ask you to define what it means for you for materials to actually be smart. And then maybe speculate, actually how that might differ from intelligence, or how can we actually think, if we think about materials, smart materials in general, or can sense and respond, but they don't really think. So how do we actually begin to speculate what we can think about?
It's one of those really sort of dorky, titles of the Smart Materials Competition is the title. We inherited that, and I probably agree. I don't think there's smart materials or dumb materials or challenged materials. They're all kind of fine with this. I think it's how you use it. You can use them smartly or not so smartly. So I think, and we were really thinking about the whole rhetoric of this kind of sustainability stuff and smartness and high tech and low tech. So for us, it was about utility. How do you use something? And that's where with Matthias and Mike, at the beginning, we're like, well, what's concrete? What can it do that paper can't do or something else can't do? So I think it was about being cognizant of what the what the potential or the possibilities with these kinds of material was. So I don't think, there's probably some bad materials in terms of issues like, say, sustainability, but I think it was really about, it's like that first year thing, when you have a piece of paper and some scissors, what can you do with it? So it was really about the kind of potential of working with something, so we, in a way, with this project, we wanted to get as far away as we could from the whole kind of rhetoric of sustainability and smartness and all of these things that we were being confronted with, simply to, but at the same time, to force ourselves to work differently. And again, I think it would be this idea about, say, synthetic or in a more inclusive way. So in a way, that was what the equivalency for us in terms of, say, design intelligence was this kind of, which again talks about efficiencies and the economics of the project and all these things at once.
Other question? Eric? There's one there.
That was a really fantastic project with the, as an explication of taking an idea and making it a project or a building, which is how we started. I'm just wondering, it's so seductive, the way that you are forming those block elements, and they become really the highlight of the project, both because you're forming them in a way that sort of catches the eye, but also because of the way that they perform and the way they stack. Was there a moment in the project that you thought some other element was going to be sort of the star of the project before that concrete system took that form?
Well, yeah, I mean, I think we're still old-fashioned in the sense of we believe in space making, you know. So if you thought about the project in a kind of sectional figure ground way, maybe we were thinking about how it spatialized both a kind of exterior surface, it became balconies, you know, straightforward. An interior could be like a loft, or it might simply be a small sleeping room with a kind of articulated wall that conditioned light through it. So in a way, we're making these things and they're objects and they go together, but at the same time, we are very interested in the whole phenomenological aspect of how these things condition space, how you would occupy them, how you would experience it. So I think, you know, all that, you know.
I don't mean to say seductive in a negative way.
No, I don't either.
Yeah.
But I think at the end it's still, you know, it's an architectural project. So, and again, well, we like the nuts and bolts and the kind of killer part aspect of them. We like it how it works as architecture, and maybe in the kind of good old-fashioned sense of the word, what the effects of those things are in terms of, say, conditioning space, program, experience, use, time.
It's quite a bundle.
Well, I think we are in time. I just want to add some words on what Frank has said. I think that when he was trying to escape from this kind of smart or this kind of lexicons, I think that in his talk he has been very focused in we haven't seen any blue or red arrow, we haven't seen this stuff. We have seen, for instance, relatives to matter, form, our body or our experience, and history. And I think this is the references in history. I think this is the point that when he's reivindicating the role of the architect, or Eric, the role of the architect in all this idea of adapting to new conditions and the new values, our construction systems, I think that coming back to these very old-fashioned words, form, matter, history, body, I think is key. So thank you so much, Frank.
Yeah, thanks.